Okay, we are going to return to trying to build a um, Sega Megadrive controller tester. So we've already done one of these, and I had one. Where did I put it? I had it already and set to go. So this is my previous one that's built with an Arduino. I've actually changed this very slightly, and I'm going to show what I've done. You can guess. I changed that into a nice and sensible green LED. So now it looks really cool and green, which is much better than the red one. But this one has that funny thing where it gives you a number for the button that you're pressing. We're going to make a different one. We're going to make one that doesn't use an Arduino. So I thought that would be an interesting, fun little challenge. So I have a little diagram. I think I had a diagram. Of course, now that I actually go to do this, I don't know where I put it. Oh, here it is. So remember, there's nine pins on the 9-pin connector. They are numbered 1, 2, 3. We've all gone through that. This is actually matches up to what the standard descriptions of the connector is on the internet, and that will basically be that you have these pins. So if you don't know anything about these controllers, just go back and look at quite a few videos now that I've done specifically about these controllers, making a tester and making making an example one, which I don't actually know where I've put it at the moment. It's around here somewhere. I should have got that out. We will be using that to test it. I don't think I'm actually going to get to the point where I'm going to test it today. So I'm going to test it with my fake controller instead of using the real controller, so that I don't blow up another one. So basically you have 9 pins, as you can see here, 9 little inputs, 9 little connections, and they have basically, most of them have 2 functions. So some of these, you've got your ground here, it's a power, pin 8 is the ground, pin 5 is 5 volts, which is actually quite nice, like pin 5 volts. And select is actually provided by the computer, or the tester in this case here. So the tester is going to be setting what select is. So when select is high, then pin 1 will be low when the up is pressed down, and pin 2 will be low when down is pressed down, and left will be low when left is pressed down. 3 will be low when left is pressed down, 4 when right is pressed down, 6 when button B is pressed down, and 9 when button C is pressed down. But when select is low, then these 2 things are the same, but these become ground, and those become that's the 7 now represents the select button, and 9 represents the start button. So this thing here is going to be a slight problem because they go ground when you have select low, but that basically says the button is pressed down. So this is going to cause a little bit of extra circuitry, which I don't think we're going to worry about today. We'll just get to the point where what will happen is left and right will always be on. Up and down, basically we can just pass them through and ignore this because they're not part of the internal structure of this. So if you remember what we did to build the example one, we used the 74HC157, which is basically you take 8 inputs and then you can divide them into 2 with the selecting, which is 1. And so in order to do the opposite and to test it, we're going to have to sort of take these 2 sets of values, excluding these ones, excluding up and down, because up and down we can just ignore. We'll just have those wired up like in a standard Atari style joystick connector tester. So I don't know where the little Atari tester thing went that I made, but I don't care anymore about that because I've got this thing, and this thing will do Atari ones. But the way it's going to work, I didn't actually draw in the middle. So these here are going to be a mysterious IC, and these are the pins that we care about. So pin 3, 4. I mean, we care about them all. I'm just going to say these are the pins that are interesting for this project. 3, 4, 6, and 9, which are these ones here. So they're the ones that are altered by what select is. And so this is meant to me saying that basically pin 3 goes into into this IC, and it also goes into this IC. And we're going to talk about this IC in a minute. Then we've got LEDs. Actually, this should be, I've gone and put ground there, but that should actually be 5 volts. I can't draw upside down. 5V. Maybe I can draw upside down. 5. Is that actually, hold on. Is that an actual 5? Oh my goodness, it is an actual 5. And look at the inks come through on the side. So what are these mysterious? Well, the idea is basically we're going to be feeding these two things here into here, but these are latches, so the output will depend on whether or not they're being latched. So the idea will be is that the inputs will go in here when we select is high. So the inputs are always going into here, but when select is high, we're going to latch the inputs to these outputs, and when select is low, we're going to latch the inputs to these. So these things are always receiving the same inputs, but they're only latching it across to the outputs when the right time comes. So that's the kind of idea. It'll make sense as we go along. Yeah. So remember that the button is down when you're pressing. When you're pressing the button, it is pulled to ground, so the output will be low, which is why I've got these are meant to be light emitting diodes, and there's obviously a current limiting resistor in there somewhere, and that's going to be going from 5 volts there, so that it will turn on when it's pulled to ground, is the theory. Of course, the outputs might not actually be that close. Well, it'll be fine. It'll be fine. So what IC am I going to use here? So we're going to use quite a few ICs in this thing. The first one, this is the one that we haven't touched before, which I'm going to be using a 74HC 574, and the reason for that, propeller with things falling off the roof. The reason for that is that I bought a whole pile of them actually a while ago, and I've been trying to find a use for them. So here's a couple here. I got 70, I think, quite cheaply. And at the time I thought, well, these aren't very useful. I'll never use these for anything. But they'll be used here. Unfortunately, they take 8 input. Well, it's not unfortunate. It's not unfortunately. It's just that they take 8 things, and then they have a latch. So basically, on a positive rising edge to the clock pulse, so the positive pulse, I'm going to draw it, I don't know where I should draw it actually. So when the clock goes like this, so from low to high, whatever is on the inputs will get latched to the outputs. Otherwise you can change these around, and at no point will the outputs change. So that's pretty straightforward. There's actually so an earlier one, which is the 74HC374, which is very, very similar. Like the description will be exactly the same, I think. The only thing that I can tell the difference, I lost my book that had a picture of the diagram of that chip, of the 374. But the main difference that I can see is that the 374 is all completely illogical. Everything's all over the show, and so the pins don't line up. It's basically a 4017 style deal where all the pins are all over the show. Where here, everything is nice and neatly ordered, right? So you've got everything, like the power pins, the power pins over here, and then you've got the inputs here and the outputs here, and they all line up nicely. And then you've got the 2 extra ones. So there's an output enable which has to be pulled low. I don't think we'll be messing around with that. And then there's the clock, which will be here. And so then the next step, of course, is how I'm going to do this. So I didn't draw a diagram for it, but the naive way, I think, would be you just basically, so we're going to have a clock. So we're going to have a 555 timer thing in here, but I'm just going to use one of these little things, these little tiny 555s. So this is going to be sending out little clock pulses. I don't know which one I should draw this on. I do have a spare piece of paper here. Hold on. I'm going to draw it on these two and hopefully not make a mess and everything else. This one's already got marks on it. So the clock pulse will look like this. Right, so this gives you some nice rising edges, but we can also invert that, and then we'll get we'll get like an opposite pulse here. and the idea would be is that, you know, so at this point here, when this basically the input would go into select. So this would be select. So this point here, this time here, select would be low, and then select would be high, select would be low, select would be high, and then to latch the first one, so select is low, and then we're going to use this rising edge to latch the first part of it. So all the all the low things, so this is the low things, they will be latched in. So my IC handling the outputs for start, select, and that's pretty much it, will be latched on this rising pulse. And then over here, since we've inverted it, but at this point here, so we latch it at this time point, latching here, and we're also switching over to select being high. So when select is high, then we'll latch again, but this time we'll latch for the second set over here, because this will be a rising edge pulse. So the inverted waveform from the 555. So we'll just use a 4049 to do that. Will then latch onto the second set. So first set, select is set to 0. There's a latch, and then select becomes 1, and then there's a latch for that one, and then this set gets set up. Hopefully that makes some kind of sense. It will all make sense at the end. The only thing, the reason that I don't think that was going to be a very good idea. Like, I think if you made it, it might work. But there's all these sort of contentious things. Like if I have this clock pulse here, how fast is the 157 on the controller? It might have gone, well, look, okay, well now select is high, so I'm going to quickly switch over to the high outputs, where I was trying to read from the low outputs. So, you know, there's a sort of race condition. It's very contentious. It's like, since I'm a computer scientist, this makes me nervous, and I'm pretty sure if you're an engineer, an electrical engineer, this would make you nervous as well, because you can't really rely on what will actually be the outputs from the controller at that particular point, because you're swapping between those. So if you're sharing those two things, it becomes confusing. So what I thought I'd do is we're going to use 4017, and we're basically going to cycle through 4 different states. So I wasn't actually going to say I was going to use a 4017 until I finished doing this, but basically there are 4 states, and we cycle through all of these states. There is another picture that I have drawn, and I seem to have lost it, and this makes it kind of annoying, because I think that was the one that actually was going. Where did I put it? Did I actually draw it? I don't think I did. I knew there was something I hadn't finished doing. Well, we'll see how this goes, and I'll make it up for the next video. But basically, you have 4 states. So in the first state, we set select to be 0. So I'm gonna say it in a particular way, which is not going to match up to how you actually do it, but I sort of like giving the intuition for it. So on the state of 1, first thing, we set select to be 0. And then sometime later, while select is now 0, we latch the first set. So we have a clock pulse that goes up. And then after that, we set the select to high, and then sometime later, we set the latch. We latch the second set. So that was kind of the idea, and I'm going to use so instead of the 555 being directly clocking everything, it's going to be clocking the 4017, and the 4017 is just going to be outputting pulses on the first 4 outputs in order over and over and over again. So basically, the way to think about this, so I sort of said that on the first state we set select to be 0. As though it was a computer program or something. But that's not how we're really going to be doing it. And what we're going to be saying is if, so the value of select will be low if state 1 or 2, if we're in state 1 or 2. So basically, if there's a high on either pin 1 output, whatever that is, you know, the output 1 from the 4017, or the output from pin 2 is high, the output will be low. So that's actually, that should sound very much like a NOR gate. That basically is a NOR gate. So if this or this is true, is high, sorry, then the output will be low, which is what a NOR gate is. And similarly, over here, if either of these is high, we want select to be high. So that's an OR gate, so either or. So in this case here, if this was low and this was low, so both of these are low, then the output will be high. In fact, now that I've actually just said that, I don't even have to worry. So I was actually going to have another NOR gate over here, and then invert it. So I was just going to try and use just use NOR gates and not introduce any other gates. So we have a NOR gate and then we invert it. So if this one is high or this one is high, then we output high here. So to create an OR gate from a NOR gate, you take an OR gate and then you invert the output by making a little tied together. Where's my little book? It's bound to have that exact picture in it. It's right here. This book here. So we'll just quickly go to the 4001. So we could have just used the other one. There. So there's the picture of how to make an OR gate out of a NOR gate. But now that I just foolishly said it out loud, of course, if this or this is 0, then the output will be high. So that's what a NOR gate is. So if either of these are high, the output will be if both of these are low, the output is high. So that's essentially what another way of looking at a NOR gate. The only way the output is high is when both the inputs are low, and that both the inputs are low only when either of these are high. So I don't actually need another gate. This actually will supply. If I just look at this thing here and use a NOR gate, I've got my select. So that will be low when these two are we're in these two states, and it will be high when we're in these two states, because it will be high because we're not in these two states. So it works quite well here. And then all we have to do for the latch pulse is just take the rising edge. So when we go from 1 to 2, so basically we just feed in the output from output 2 from the 4017, and that will be our latch pulse. And output 4 will be our latch pulse for the second one. So we don't have to do any messing around, and we've just had to use one part of the NOR gate, which is good because then I can use the remainder of the NOR gate, I hope, though I might need another one, to fix up the problem with this part here, but we'll leave it for now. And the reason that I'm just saying that is that this will always read potentially as, well, maybe it won't. I never really thought this through. We just don't actually, because there's only 1, 2. No, I don't actually think this is really gonna matter. Oh no, it might. I don't know. We'll find out. I don't think it does matter actually. I think about it. So that's basically the plan. So let's just actually get some of this made up with the 10 minutes I've got left. Let's just knock out some of these. So I've put this in already, and it goes 1, 2, 3 that way for me. And I've got another one of these sitting here just in case we need another one, except this is the wrong style and won't actually clip on to the side, which is annoying. Well, I've got this thing here as well, so I could use this. I've got quite a few of these little boards. This one's really old. I thought maybe I'll use a bigger thing. And I've got a supply of random ICs over there as well. So let's just get this. So the only other thing is, because I need to have 2 separate latch blocks. So 2 separate things here. Even though there are 8 inputs to a 574, the 74 HC574, I can't actually use them because they have to be latched separately. So I'm going to have to use 2 separate 574s to get this to work. But that sounds like a waste. But then I could make, like in the final production of this device, you could just use both of these, and so you could have 2. Basically, you could have 2 connectors. So you could be testing 2 joysticks at once. So these could be providing outputs for 2 separate things, and that way we'd use up. So this one would have the first 4 buttons for joystick 1, joypad 1, and also the first 4 buttons for joypad 2 as the next set along. So it's, you know, if you make it that way, which is pointless, why would you test 2 at exactly the same time? I don't know, but it could be fun. But I think the other thing is, because you might not be testing this, and actually the whole point of these things is not really to make testers, but to make converters between different systems. And so it would be quite nice if you could convert from, say, you know, so ultimately we're going to be like using a Mega Drive controller on like a Nintendo Entertainment System or something, or a SNES. Or actually, the next one up we'll probably have a quick look at will be the Commodore CD32 controller, for fun, because I'm always kind of keen to work out how that one works. I think it actually works very similar to the SNES style ones, but I'm not entirely sure. So these are correct. I'm just double checking. I've never used these, so I'll just open them from their packet. I've just got to get out my picture. Thankfully I've got this one piece of paper, so I don't have to have the book sitting. I really should just print everything out each time I do these things instead of reading off these books, but I like having these old books. It's quite fun. We've only got 7 minutes left, so we're just going to get around to I think I'll just put the outputs on here, so we'll just have little wires connecting across. I really have no idea how to lay this out. Well, I'm going to keep these over on this side, because we've still got to fit at least 2 other ICs on these. I think I'm probably going to need another one. I had 2 more of these boards that I haven't used yet, and I don't know where I put them. So hopefully they turn up soon, and we're going to put these right next to each other. It's going to be a real tight fit, but I don't think it's going to be a problem. And let's just get some. I'm really running low on short. Oh, I do have some more of these, and I don't know where I put them because I'm running low on these little short wires. Let's just do the power first. Well, first off, we need the output enable. So I've got these facing the wrong. Oh, I've got them facing alternative ways. Oh, okay. I've just made my first big error of the day. And that, how am I going to get this thing off now that I've gone and put them so close to each other? Well, we all make mistakes, and well, what if I do the 2 at a time? That's not going to work. Oh, well, that's kind of damaged. Whoops. All right, that's all right. We can do this. Okay, so I'm going to have the picture looking that way. All right, that way. So I want them to be facing there. It's not broken. Okay. It's not going in very well. Okay, I'm going to squash it in again on this thing. It's still not going in very well. That leg is really stuffed. That leg is really stuffed. Could have been worse. There we go, that one's gone in. It's fine, I saved it. It's all good. I honestly, you know, I do appreciate these ICs coming along, giving up their time. So I'm not gonna make the same mistake either. Hold on, I need to make sure that I still have enough space. There we go. One little bit. So now I have space to take it out properly. There we go. So that's good. Except this thing doesn't really go in the middle. Like, I feel like it should be a bit thinner here. It's probably not designed for these kind of boards. Oh well. Okay, output enable has to be pulled to low, so we can do that real quick. I was going to buy a few more of these because they don't cost too much, but I got the funny feeling they're going to take quite a while to arrive, given the situation in China at the moment. But my printed circuit boards, when they come, are in the mail right to now, so I managed to get that just at the right time. So this again is a very funny looking. So pull that one to the ground. Alright, and what else we need? We need another ground over here. This is not very exciting so far. I'm gonna use, I don't care, they're all going to be the wrong colours. Don't boss me around. Well, these are the inputs. So the inputs are going to be on this side. So, or maybe I should have done them the other way around. Should have thought that through. Well, we can just move these across. It's not going to matter too much. Maybe I shouldn't have done that like on camera. And we can do this really fast. So I watched Zombieland Double Tap today. I thought it was quite fine. It was a worthy sequel, right? I like the end, but alright, so what are we up to? We are up to putting in the ground for the second one. So it's all very well matched up. How much time? 3 minutes. There's no way this is going to get done tonight. Well, that's okay. I just wanted to get a good start on it. I wouldn't want it to be just one video. My goodness, what a waste of opportunity. Oh my goodness, these are the worst connections I've ever done in my life. Oh well, what can you do? Try harder, put more effort into things. That's always an option, but not one that I'm particularly fond of. Right, wish these, I don't know, I don't have any ones that are just that little bit longer. I feel like I really didn't plan this out, did I? Okay, next time, okay, first thing, orientate the IC so that the positive lines are closer to the thing, and then I could have used the smaller ones to connect them up. And now I have to use these ridiculously large, because I seem to have lost the middle ground ones, wires to connect everything up. But it's hardly going to be the end of the world. It's hardly going to be a zombie apocalypse. Though really, we shouldn't be making comments like that, given the currents. It's not going to be the end of the world due to COVID-19, 2019 or whatever. But it could be a pretty bad day. Alright, who knows. Alright, so now I have to look at my little diagram again. I've also just sort of realized that maybe I should have just put, oh no, I'm not going to move, I'm not going to move. Okay, the support ICs are just going to go over there because I haven't got the energy to do that, and we're just going to use the rubbish wires because I don't have the energy to do anything else. So we need the first, wait, so these ones are going to go, let's just work this out. I've only got a minute left. Okay, we'll just do the first lot. So the wire, the pins are pin number 3, which is this one. No, it's not. It's that one. Okay, hold on. We'll do it the other way around. Pin number 9, which is this one. Pin number 6, which is this one. Pin. Oh, not doing them in order. Okay, got to get this order right. And a bit closer. Pin. Alright, that one there. 30 something seconds left before the camera quits. And 3 and 4. Which I think is those 2. And we can take that one. 24 seconds left. Alright, and then they are just basically going to go straight on to here. It doesn't really matter which way around, because all I want is an LED to come on when I press the button. Alright, so that was it. We've got 7 seconds left. That's the first part. We're doing it, and we're going to finish it off the next video.